रमनीक, 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 एज यूजुअल आपका वीडियो ऑफ आ रहा है, अपना ऑफ आ रहा है साउंड। कल भी यही प्रॉब्लम थी।
सर मुझे को होस्ट बना दीजिए सो दैट। गुड आफ्टरनून सर।
को होस्ट आपको बना लिया गया है।
और सर मैंने अभी अनम्यूट का मुझे अभी
आप चेक
ऑप्शन
करिए,
आया,
आपको
पहले
बनाया
नहीं
था
आया।
को होस्ट।
मैं चेक करती हूँ सर, एक सेकंड प्लीज।
ये प्रॉब्लम नहीं आनी चाहिए, कल बहुत ज्यादा प्रॉब्लम आई थी।
जी जी जी
नहीं तो आप उसको कौशिक से बात करिए।
जी जी जी। हाँ, नाउ आई एम द को होस्ट सर। अब मैं बनी
आपकी
हूँ
आवाज भी
co-host।
नहीं आ रही अब। हाँ,
Am I
रमनीक को
audible
को
now
होस्ट
sir?
नहीं है।
Am I audible sir?
नो, आवाज बहुत कम आ रही है।
अभी भी?
हाँ, अब ठीक है।
ठीक है सर।
अच्छा, एक और
हाँ जी
रिक्वेस्ट
सर।
रमनीक करते हैं कि जो जो लोग ऑडियंस में है, हमारे फ्रेंड्स, उनको आप एक दो बारी बीच में रिक्वेस्ट कर लो कि दे कैन पुट देयर वीडियो ऑफ, बिकॉज उससे ना स्क्रीन पे कंफ्यूजन होता है ना।
ठीक है जी, ठीक है जी, डेफिनेटली सर।
हाँ
हाँ जी
हाँ, आप रिक्वेस्ट कर लो
जी
सभी को,
जी
और
जी
बीच
सर।
बीच में करते रहना।
जी जी जी, डेफिनेटली सर।
हमारा
तो
जो
सर आई
शेड्यूल
हैव।
है आज, रमनीक,
हाँ जी हाँ जी। हाँ जी सर, हाँ जी।
हमारा शेड्यूल है आज, हम शेड्यूल के मुताबिक जाने चलने की कोशिश करेंगे।
जी जी जी।
वी हैव टू स्टार्ट एट डॉट
2:30
2:40।
2:40। ठीक है जी, डेफिनेटली।
2:40 से एक मिनट पहले ही शुरू कर देना है हमने।
ठीक है जी। I'll start. We have
8 मिनट्स टू गो।
around। Yes sir। हम कर लेते हैं स्टार्ट, कोई प्रॉब्लम नहीं सर।
हाँ, और जो
अभी
स्पीकर जिन्होंने बोलना है उनके नंबर लेके एक बार चेक कर लो, वो आ गए सारे, जो नहीं आए तो उनको बुला लो।
ठीक है जी, मैं चेक कर लेती हूँ सर। और मेरी वॉइस और मेरी वीडियो, द लाइट ऑल ओके सर?
हाँ, ऑल ओके, यस।
ठीक है जी, अभी मैं उन सबको अलर्ट कर देती हूँ, दोस्त हुआ मैं अपनी वीडियो ऑफ कर रही हूँ सर। ठीक है सर?
हाँ जी।
ओके सर।
जो भी हमारे फ्रेंड्स ऑडियंस में हैं उनको मैं रिक्वेस्ट करूंगा कि वो अपने वीडियोस ऑफ कर लें प्लीज।
Baga sir,
Yes.
can we start? Can we start in a minute? In a minute
Wait
or
for
two?
2
ठीक है जी,
minutes.
Okay, all right, sir. All right, sir.
Ramneek, we have to check whether our speakers have joined or not, and if anybody is missing.
जी, definitely, sir. I'm checking that.
Speaker join करे कौन रह गया, फोन कर दिया।
श्रुति मैम से बात होगी और शिल्पा मैम से बात होगी, वो करने लगे।
और बाकी के,
हाँ, बाकी के भी करने लग रहे हैं, सारे सभी से कॉल करके बात कर। अब स्टार्ट करो।
Baga sir, I've
Yes.
texted all the speakers. I've just texted all the speakers. I've asked them to join. I hope they have entered the room.
They are joining. We are coordinating. Just give it 1 minute.
Definitely, sir.
हाँ. ज्योति मैम, आप वीडियो ऑफ कर लें तो बहुत अच्छा रहेगा। ज्योति मैम,
I request all the attendees to kindly please switch off their videos and kindly unmute them. Sorry, mute them. I request all the people in this seminar who've joined. I request everybody who've joined the video to stop their video and mute their audios.
वेलकम श्रुति मैम। बाकी लोग आ रहे हैं? ओके, रमनीक जी, रमनीक, रमनीक,
Yes, sir, I am here, sir.
Yes, please. Ramnik, start now.
Yes. Can we start now, sir?
Yes.
I hope everybody is here.
Yeah. Don't worry, you start.
Ji. So good afternoon, ladies and gentlemen. Hope you're all doing very well this fine day. I am architect Ramneek Kadiyal, and I welcome you all today for this occasion. We are assembled here for a very special purpose, that is to participate in the deliberations of webinar on energy conservation and energy efficiency. This program is initiated on the behalf of Punjab Energy Development Agency, PEDA, and we are pleased to share that PEDA is celebrating Energy Conservation Week in this entire state of Punjab. Sakar Foundation from Chandigarh has been given the responsibilities of organizing 7 webinars from 18 to 26 February 2021, daily from 2:30 p.m. to 4:30 p.m., except for Saturday and Sunday. I extend my warm welcome to all the members from Department of Government, local government, and impaneled ECBC professionals for the participation in the webinar. I now invite architect Shruti Kapoor to give the welcome address. Over to you, Shruti ma'am.
Good afternoon, everyone. Hope I'm audible to all.
Yes, you are, ma'am. Yes, you are.
Thank you. First of all, thanks a lot for giving me this opportunity to speak over here on this platform. Today event, it is organized by Punjab Energy Development Agency, that is PEDA, and that is in coordination with Sakar Foundation, Chandigarh. We welcome all official. It is on behalf of PEDA as well as Sakar Foundation. I welcome, as well as those guys, they welcome all official staff members, authorities of PEDA to this program. We extend our warm welcome to all the officers, staff of Department of Local Government, and empaneled ECBC experts for their participation in this webinar and other professionals. Along with this, I would like to welcome Shilpa Das ma'am. She is a practicing architect from Chandigarh, and she is going to deliver theme address today. We also welcome today's star as well as prominent speakers, architect Surinder Baga, engineer Balkar Singh, engineer Shiv Kumar Batra, architect Pritpal Singh Aluwalia, engineer Anuj Agarwal. We highly appreciate them as they have spared their valuable time to share their knowledge with us. In addition, I would like to welcome our supporting organizations, that is Indian Institute of Architects Punjab chapter, all its members, executive members, office bearers of IIA Chandigarh and Punjab chapter. Along with this, I would like to welcome architect Ramneek. She is going to be a comparer today and she has already started and doing well. Thank you very much. Last but not the least, we welcome architect Dinesh Bhagatji. He'll be presenting vote of thanks in the end. And I congratulate all the members who are involved and hope this event will be beneficial as well as informative to all the participants. Thank you very much. Over to you, Ramneek ma'am.
Thank you so much, ma'am. Now I invite architect Shilpa Das. She is a graduate from CCA Chandigarh and she set up a private practice in the year 2006 in a quest for a better living spaces, taking up the challenge to contribute towards filling this void. And she has been instrumental in creating a forum of like-minded professionals and citizens. I request architect Shilpa Das to please address the audience. I hope we have architect Shilpa Das here with us.
Yes.
Architect Shilpa Das.
मैम, शिल्पा मैम आपको अनम्यूट करना पड़ेगा. शिल्पा मैम का स्पीकर बंद है.
Architect Shilpa Das, I think you have to unmute yourself.
Am I audible?
Yes, ma'am. Yes.
A very good afternoon to all present here today. It is a matter of privilege for me to be addressing this forum on day 2 of the Energy Conservation Week being celebrated in the state of Punjab by Punjab Energy Development Agency, PEDA. Energy conservation, we know, is about an efficient use of energy resources. For us architects, engineers, and designers, it means designing buildings in a thoughtful and responsible manner, from the design of the building to the choice of materials to the equipment selection that is required to run and maintain the building. Actually, it is much more than checking the boxes for a compliance and certification. It is a way of life. We have to keep reminding ourselves through such discussions, as well as during the course of normal life, as to why we need to be conscious about efficient use of energy. It is very easy, after all, to fall into the trap of, if I can afford it, why should I care? So we, the human race, needs to remind ourselves that the earth we inhabit is home to many more. We must consume its resources graciously as is necessary and leave the place in a respectable condition for the others after and around us. Only us humans have the faculty of choice. Once this realization is there, remaining is of course spontaneous. I congratulate the organizers, Sakar Foundation, for beautifully putting together this meaningful event with an expert panel to share their knowledge on the subject with us today. We will begin with the insights of Mr. Surinder Bhaga on energy efficient architecture. Engineer Balkar Singh, retired Joint Director PEDA, will take us through the advantages of star-labeled electrical appliances. Engineer Shiv Kumar Batra will refresh our knowledge on the intricacies of lighting. Architect Pritpal Singh from Patiala will then be throwing light on energy-efficient building materials that is sure to help us make informed choices. And lastly, the important subject of HVAC will be covered by Engineer Anuj Agarwal. Without further ado, we begin with the enlightening one-hour journey, listening to and learning from the esteemed speakers of the day. Have a good time. Let's begin.
Thank you very much, Architect Shilpa Das and Architect Shruti Kapoor. We are really delighted to have you here. Now, without further ado, energy efficiency describes how much useful work is extracted from one unit of energy. Remember that although energy is not created or destroyed, it is just transferred from one form to another. Some energy is nearly lost in the transfer as heat, as we all know. We've all studied in the lower classes. By saying that work must be useful, useful must subtract the energy that is lost to non-useful work. For example, some energy may not be doing the useful work if the equipment is not running well. In this week-long program, we shall be organizing exclusive webinars for different departments and organizations of government, semi-government, and private departments which are working with Punjab State. These webinars are specially designed to talk on different subjects like energy efficiency, energy efficient architecture, green materials, energy efficient lighting, HVAC, star labeled appliances, etc. as Architect Shilpa Das briefed us. So today's eminent speakers who are invited are special accredited professionals which have great experience in the field of energy conservation and energy efficiency. So to begin with, we have our first talk by Architect Surinder Bhaga on energy efficient architecture. Architect Surinder Bhaga has established architecture organization Sakar Foundation in Chandigarh in 1984. He worked as a chairman of IIA Chandigarh Punjab chapter, chairman of IIA Publication Board and editor of Journal of Indian Institute of Architects and nominated as councillor in Chandigarh Municipal Corporation. He worked as a member of High-Powered Finance Committee of Chandigarh Municipal Corporation. He was chairman of Chandigarh Municipal Corporation's Committee for Building and Roads. Currently, he is member of Advisory Committee on India's Home Minister on Union Territories. Recently, he has been appointed as head of Chandigarh sub-chapter of FSAI and chairman of GEM Chandigarh chapter. He has co-authored 3 books, namely Modern Architecture in India, Post-Independence Perspective, New Indian Homes, Le Corbusier and Pierre Jeanneret Footprints on the Sands of Indian Architecture. He will now be addressing our audience. Over to you, sir.
Thank you, Ramnik. Thank you so much. First of all, we are grateful to PEDA for giving us this opportunity to bring so many experts and professionals together. We are especially thankful to the team which is going to speak today. My topic today is energy efficient architecture. Yesterday, I delivered a talk on the same subject, but the content today is different with a slight repetition. So those who attended yesterday, they can attend today also because it is not exactly the same. First of all, I would like to show you some shlokas from the holy scriptures, the holy books. This one is from Holy Purana, the Hindu scripture. It highlights the importance of a tree in our life. Likewise, there are many shlokas in Holy Guru Granth Sahib Ji, which are, telling the mankind, advising the mankind to safeguard the environment. Similarly, this the Holy Quran has many verses, ayat bahut sari usme hai, which are telling the human race to protect the Mother Earth. In Bible also, there are similar verses. So the point I am making is in all religions, in all holy scriptures, there's a lot of emphasis on saving the environment, saving the Mother Earth. So today I will be taking you to some knowledge, some experiences which we have. India is a huge country, a big country. It's a rather subcontinent, and it is further subdivided climatically into 5 climatic zones. The top, as you can see in this Indian map, the top portion of Jammu Kashmir and parts of Himachal, etc., is falling in cold and cloudy region. Composite region is Punjab and many parts of central India, which is shown in a light golden color. Hot and dry region is Rajasthan and parts of Gujarat. Warm and humid region is the coastal belt, and moderate region is a small pocket somewhere near Pondicherry. First of all, I will speak about the composite region where most of India is falling in this portion, including Punjab. When we design buildings in a composite region, there are certain guidelines, there are certain design strategies. Like we have to resist heat gain in summer, and we have to resist heat loss in winter. This is the design strategy. And how we can do it? We can orient the buildings in a facing north-south. We can have roof insulation, we can have wall insulation, we can provide thicker walls or cavity walls, etc. And we have to promote heat loss in summers and monsoons. Either we can adopt courtyards or winters or arrangement of openings and so on. I will show you this project. It's a Baptist church in Chandigarh. This church is designed by us, and it is rated as one of the best 41 buildings in India by Terry and the government of India. And it is published in a publication brought out by Ministry of Renewable Resources. This particular church have cavity walls. This church have small openings. You can see the vaulted roof is painted with a white color so that incident sun rays are reflected. And likewise, we experience that this church remains nearly 5 degrees cooler than the normal conventional buildings in that vicinity. You can see in the plan, the cavity wall is enveloping the whole plan. Then Bal Bhavan is another structure designed by us in Mohali. In this project also, this is the western side. We put together all the toilets on the western side because we needed huge toilets for the students who will be living there. Lot of training programs are conducted there, and lot many students come there and stay there. So we needed many toilets. What we did is we put together all the toilets, and toilets are placed on the western direction, so that during the western sun, this these toilets get heated up, but the heat is not further transmitted to the interiors. Likewise, you can see in this picture, all the windows are properly protected. There are thick walls, and building functions quite well even in hot summers. And another project is a Yadvindra Public School, which we have got through a competition project. And in this project, you can see the existing school was designed by J.K. Chaudhary, a very famous architect who happened to design the Punjab University campus before Piri Jamre came in. And in this project, you can see we have taken care that not even a single tree is cut, because the site is dotted with lot many trees, and we got the competition on the major point, which was in our favor, was that we have not allowed any tree to cut. And we have shielded all the windows, you can see, and the architectural vocabulary of this school is matching with the existing school, because we do not want to create a structure which is not fitting in the campus. This is a plan of the school. You can see a 7-meter wide corridor in the middle, and that corridor is having cutouts on the either side. And these cutouts are, protecting the classrooms from the noise which is emanating from corridors. And you see this cross section. This central corridor, which is 7-meter wide, having cutouts on the either side, it facilitates the air movement. Plus, it insulates the classrooms from noise, and it brings in a lot of light from the top. And that, you see how it looks in the interior. There's a lot of light in the interiors, in the central corridor. No artificial lighting is required. There's a proper ventilation, and at the same time, it facilitates the air movement properly. Then we happen to design a youth hostel in Patiala in Punjab long back. Here, we have taken care of the same climatic conditions which we are in. In this, you can see this picture. We have staggered balconies, and these staggered balconies are about 6 feet deep, and they all the larger windows and doors and glazings are properly protected from heat and from the solar heat. And the rainwater is drained through spouts, because in public buildings, the most of the time, the pipes get choked. Then in Barnala, we designed a small nursing home, which is called Manodisha Hospital. It's a psychiatric hospital. This is the hospital. It's a recent building. You can see all the windows are properly protected from bottom, top, left, right, so that the windows are protected from dust. Windows are protected from hot sun and rains. There's a small cutout in the middle which facilitates air movement. In the plan, you can see that. And this is how we protected the windows. Then the Red Cross Bhavan in Sector 16 in Chandigarh. This is the project, which got delayed by nearly 1 year, because the original zoning, which was prepared in the middle of 50s or 60s, was outdated, and that zoning was wrong. And me and Ma'am Sumit Kaur, the chief architect, then she was the chief architect of Chandigarh, we discussed that we need to revise this zoning because it is wrong. What we did is we made a revised zoning, which delayed my project for nearly 1 year, but ultimately we were able to have the right orientation, which is not, this building is facing Rose Garden now, and it is having a north and south. The larger faces are facing north and south, and the eastern and western faces are almost dead. So hence, thereby, this is the best orientation in this region, which we could achieve. This is the plan form. You see there are a number of ducts, and all the windows are properly protected, and so on. And then we got a chance to design a Christian school in Chandigarh, which is called Baptist School. In this school, you can see, again, we opted to put the toilets on the western direction. This is the toilet block on the extreme left side. And this is exactly the western side. And then you can see in the photo of the school, all the windows are properly protected with a combination of horizontal and vertical louvers. And courtyard planning, small courtyards and larger courtyards is introduced in this project. Then long back, we happened to design a church of Lady Fatima at Patiala. This is the church building. And you can see windows are hardly visible. And this is how we shielded the windows. You can see these circular embrasures, we call it. You know, this is how we put vertical slit windows, and they are further protected with a wall, which is having a circular shape in plan. And then we have a skylight on the top. And this is how windows are covered. And the resultant is the worshippers cannot see outside, yet they get proper light, and there's a proper ventilation, and the building works really very well. Then in the recent past, we designed hostels for nearly 1,000 plus postgraduate students at NIT Kurukshetra. This is meant for postgraduate students. Again, we adopted the same parameters. Each room will have a proper small balcony to dry clothes. Each room will have a proper window, door, and all the openings are properly protected with the balconies. And then, you know, we have courtyards. You can see we have a courtyard planning, and it's a very huge project spread over 30 acres and costing more than 30 crores. You see, this is how the planning is. And all the rooms are connected together at each level. These are the pictures. Then the next one is a hot and dry zone. We got a project to design a mass housing for Indian, it's a military housing project at Jaipur. And we all know that Jaipur falls in a hot and dry region, where the design strategies are, we have to resist heat gain, and we have to promote heat loss at night. Because, you know, in the evenings, you get climate is comparatively better. Then you see, this is the project. In hot and dry regions, we need to have north and south orientation, which is the best orientation in a hot and dry climate. And we have to convince the Indian military authorities by giving many presentations that we should go for this kind of a orientation, because that was the basic point which we wanted to achieve. And after a lot of struggle, we could convince the general that we want to go for this kind of a orientation. And ultimately, he was convinced and agreed. And this is the housing which was finally made. All the housing blocks, almost all the housing blocks except one, are oriented in a proper north and south direction. And you can see there's a self-shading in the facade. All the windows are properly protected. You can see in the site, it was a sand dunes type of a site. And there was hardly any trees. And whatever little trees we could find, we tried to save them while doing the planning of this project. Then next zone is warm and humid. We happen to design some projects in West Bengal, Odisha, and Assam, which are falling in this coastal belt. In this particular area, all architects are already knowing, I'm just repeating it, that there's a requirement to increase a lot of ventilation. And how we can achieve this ventilation? You know, the plan form encourages ventilation. This is a youth hostel in Odisha. You see, there's a courtyard, the plan form is separate, and there are many small openings all around. And this is how the building looks. small openings, staggered openings, and lot many openings to facilitate air movement. And this is a public building in a very remote area. Hence, we opted to have rainwater spouts against the decision of pipes. Then moderate region is a small pocket near Pondicherry. And here we could not get a chance to design any building. I'm just borrowing one example from a friend. This region is comparatively very less harsh, and architects can get liberty to design buildings with little ease. And this is a project. In this particular, it's a house. You can see earth berms are noticeable. The roof is having solar panels, and lot many other features are there, cavity walls and so on. Earth berming, insulated roof, cross ventilation is ensured. So all these features are there. Then last zone is cold and cloudy region, which is basically Kashmir. And in this region, the design strategies are totally opposite and totally different. What we architects are supposed to take care is that we have to resist heat loss, and we have to promote heat gain in these areas. And we got a chance to design a composite regional center for physically handicapped people, which are handicapped due to terrorism in Kashmir. In this project, we were advised by the local artisans and artists. Masons. I interacted with them in Kashmir, in Srinagar particularly. We were advised that there's a lot of snow which is falling on the roof, and it is very difficult to mechanically or physically clean the snow when there's a season of snowfall. So they advised me to have a roof which is having a particular angle, and we have gone for that angle, and it resulted so well that each piece of snow which falls on this roof, it falls on its own down. So there's no need for any mechanical or physical cleaning. This is the project. It got a swastik plan. There are 4 wings. Each wing got different, different function. And you can see the Google image on the right side, on the bottom right side. And then I will be briefly touching some new technologies and new success stories which are happening. Whenever we talk about solar energy, we talk about where to put the large size batteries and all that stuff. Now this technology is available that you put the solar panels on the rooftop, and with the help of a fiber optic cable, and by omitting the batteries, you can directly bring the light to the 3rd basement level. So this technology is already available. Whenever there was a road widening or something like this, we used to cut the trees first of all, which is a great, we are doing a great environmental damage. Now trees can be uprooted and planted at another location. I was in Surat the other day, where I was told by the municipal mayor that they are selling each grown-up tree with a price of rupees 2 lakhs to the builders which are making colonies and townships outside on the outskirts of Surat. That was really brilliant. Then now research is going on that these elevators, the lifts, can generate electricity for their own consumption while they move upwards and downwards. So this work is also going on. And in Varanasi, the Municipal Corporation of Varanasi is experimenting with the roads which are consuming almost 8%. 8% waste plastic is melted and it is added into the bitumen. That makes the road comparatively waterproof, and it is comparatively cheaper, and it is having a long life. and plus it is consuming the waste plastic. That is the merit of it, and it is already happening. I think we in Punjab can take lessons from this. And energy generating pavements are also there. They are made of recycled rubber, and each slab can generate 2.1 watt per hour energy. And in certain projects, this is also being experimented abroad. Then, we have noted that in multi-story buildings, we don't have much area to place solar panels. What we do is we have a tall tower, and the area of top terrace is almost filled with water tanks and other equipments. Then this new search is going on solar towers. Solar tower is what? Solar tower is having this disc kind of a equipment fitted on the outer facade. These are basically solar panels. These solar panels, disc shaped, can sense sun's direction, and they move according to the sun, like sunflower, and hence thereby they generate much more energy than any conventional building, because these discs are oriented automatically with the help of sensors to face the sun. And it is believed that if this method works, we are going to increase the energy production by nearly 30% with these sun tracking devices, which are automatically run with sensors. And there are numerous examples in Germany, in Finland, in Hong Kong, where the solar panels are used in railings, they are used in claddings, they are used in glazings, and solar panels are used in numerous ways in railings, panels, and claddings and glazings. I think we can take lessons from them, and we can make beautiful buildings which are energy efficient. And in the last, my conclusion of my talk is that time has come for architects and engineers to work together to save the Mother Earth. And India is divided into different climatic zones, and we need to design buildings to suit the requirement of each climatic zone. And with this note, I close. Thank you so much. Over to Ramnik. Ramnik, you are not audible. Ramnik, you are not audible. Can you repeat, please? Ramnik, no, आवाज नहीं आई आपकी. No. Okay. In the meantime, Ramnik, you checked your system. We will ask Balkar sir to continue. I will introduce Balkar sir is a very senior official of the Punjab government, and he has done a commendable work in the field of energy conservation. I think he devoted his entire career, and very few people will be knowing that soon he's going to get his PhD in energy conservation, and we will be celebrating that moment very soon. And may I request Balkar sir to give his presentation on star labeling electrical appliances. Balkar sir.
Thank you, Bagaji. May I have permission to share my screen, please?
Yes, sir.
Yes, sir. Permission given.
There is no sharing, right? I think that.
One second, sir. हाँ जी सर, स्टार्ट करिए। बलकार सर।
Yes, sir.
शेयरिंग रेट दीजिए सर आपको।
Yes, something missing.
कुछ प्रॉब्लम है? नीरज सर, देखना जरा क्या प्रॉब्लम है। सर की प्रेजेंटेशन नहीं आ पा रही।
Sir, you need to share your screen. There is option in between.
Yes, yes. Okay.
You just need to click that share screen.
Is
Yes,
it
sir.
visible?
Yes, sir. It
हाँ जी
is
सर।
visible.
हाँ सर, इसको फुल स्क्रीन कर दीजिए।
Okay.
Yes, yes sir, yes. Please.
So first of all, I congratulate PEDA, Bureau of Energy Efficiency, and the Sakar Foundation for celebrating this Energy Conservation Week from 18th February to 26th February 2021. And I thankful to them for giving me an opportunity to speak on the topic of star-labeled electrical appliances. So today's my talk is on the star-labeled electrical appliances. We will talk about that from where it came and how we can address it. So first of all, I would like to tell you that there is Energy Conservation Act 2001, which has been enacted, and under the act is an agency that is called as Bureau of Energy Efficiency. And function of Bureau of Energy Efficiency is take necessary measures to create awareness and disseminate information for efficient use of energy and its conservation. Then recommend the central government for notify any user or class of users of energy as designated consumer. Then develop and recommend the central government norms for processes and energy consumption standards. And develop and recommend the government minimum energy consumption standards and labeling design, where we will talk today. And another is develop and recommend to the central government specific energy conservation building code. So these are functions of the Bureau of Energy Efficiency. Then we came to the Bureau of Energy Efficiency portfolio. They are doing awareness through energy conservation awards, painting competition, and other programs. Then in building, they have also published energy conservation building code, retrofit in old buildings, residential building code is also launched. Demand side management, they are working in agriculture, municipal demand side management. Then they are also working on the National Mission for Enhanced Energy Efficiency, that in which they are working on perform, achieve, and trade, then financing of energy efficiency. And they are also star rating the electrical appliances. And 10 electrical appliances have already been made mandatory, and 16 are on voluntary stages. So the Bureau of Energy Efficiency is the administrator who is giving the star labeling of electrical appliances. So why star labeling is necessary? Wide variation in energy consumption by products of manufacturers is observed, and information on energy consumption is often not easily available, sufficient or easy to understand from the nameplates. So it leads to continued manufacture and purchase of inefficient equipment and appliances. If we go to the history, it is started in early in Portland back in 1962. Worldwide, 65 countries implemented, including California, USA in 1976. Then Australia, Canada, China, Brazil, Thailand, Japan, and the United Kingdom. And now Bureau of Energy Efficiency has made this and launched this energy stars in India. And this is you can see how the stars look like. So if we go on December 2006, when the voluntary labeling of refrigerators and air conditioning was introduced first, so brand came in. So what Bureau of Energy Efficiency star label says? First, it says more stars, more saving. So star rating is being given from 1 star to 5 star, and the 5-star rated appliances is the most energy efficient. So second is efficiency parameter. It gives efficiency parameters, brand and model details, technical parameters, applicable details of standards, and manufacturing years. These are all given on the star labeling. So this type of star labeling is there. There is a comparative labeling for appliances. These are main appliances where air conditioning and refrigerations are there. This is for TVs. This is for the labeling for the tube lights. And these are different type of labeling, but the labeling is from 1 star to 5 star, and 5 star is the most energy efficient appliances. Now, how we can read this B star label? How we can read its description? So first is star, 1 star to 5 stars, and this is the label of 3 stars. So more stars, more savings. When comparing similar sized products, look for more stars and save money. Then another is giving efficiency parameter, that is energy efficiency ratio. So lower electricity consumption means higher saving. Sometimes efficiency is written where higher is better. So you can see that in the next description is a label period. So you must read that what is the label period? Is it now valid or not valid? So like as this in this label period it was 1st June to 2015 to 1st December 2018. You will have to see this. At present, is it valid or not valid? So next is it is given brand, model, year of manufacturing. All things are given on the label. So this is the label of a direct cool refrigerator, which was available in 2016 as a 5 star, and in 2018 it was revised as 3 star. So next you can see that technical details, technical parameters with respect to the appliances type, what type of appliances is there. Then applicable conditions are written over here. Then unique codes are written over here. Then special code is given to the rated appliances. So these are the BE star label descriptions, which you can see while purchasing any electrical appliances. This is the color television and LPG stove label. You can see this. It is such type of label here, and annual energy consumption is given 88. Brand is given, model number is given, equipment type, screen size. Then there is a condition under test conditions when tested in accordance with the relevant standards. Actual energy consumption will depend on how the equipment is used. So these are given on the label, and this is the labeling of tube light, fluorescent tube light. This is a long one, and you can see that on the star rating: first star, 1 star, 2 star, 3 star, 4 star, and 5 star. And the lumens per watt at 100 hours, at 2000 hours, at 3005 hours is given over here star wise. So you can see the description and purchase the electrical appliances more energy efficient. So you must know that there is a period of label, like as frost-free refrigerator, star labeling upgraded. In 2006 to 2011, 1 star to 5 star. Then in 2012, 2013, it has been revived. 5 star made 4 star, then 2 star made 1 star, and upgradation is there. Then you can see that in 2006, 5 star was, in 2012, it was 4 star, and in 2014, it was 2 star. And now it is star 1. So when we are traveling from 2006, now at that time it was 5 star, and now it is a star 1. So efficiency rating is being revised because more efficient products, more efficient appliances is coming from in future. So this is the room AC star level upgradation. Split AC. Split AC, it has been also revised, and you can see 5 star came 4 star, then 4 star, 3 star, then 3 star goes to now 1 star. So you can see that in 2016, 2017, the star level of star 1, the energy efficiency ratio was 2.7, and star 5 is energy efficiency ratio 3.1. So by increasing energy efficiency ratio, you can get more energy efficiency. This is for the room AC, star labeling, window AC. And 5 star now in 2014, 4 star, then it goes to 4 star also in 2017. And minimum EER and maximum EER is given over here. Now, when we are going to the 1.5 ton split air conditioner, which is being used maximum, energy and cost saving you can calculate from here, from 1 star to 5 star. So in 5 star, EER is 3.5, and cooling capacity you can see that 50 to 100 watt. Input power is 1486, and unit consumed is 12 unit. In base star, there is 17. In 1 star, it is 15. But in 5 star, the unit consumed is only 12 unit. And if we can calculate at the rate of ₹4, then you can see that the electricity cost is 1,440. And from the base, it is a difference of almost 3,000 per year. if we take it electricity rate as 4, but we are experiencing here 8 to 10 rupees in Punjab, and there is more saving, double the saving in Punjab. So if we go to the distribution transformers, and distribution transformers are also energy guzzler, and they are required to be installed as star rated distribution transformers. So when this table is valid up to 13 June 2017, you can see here in Punjab, government has notified that 4-star labeled distribution transformer is required to be used, and there you can say the maximum loss at maximum loss is there 50%, there is 135 watt, and at maximum losses of 100%, 440 watt. So this was actually notified up to 2018, and now it has been revised rating after 2017 up to 200 kVA. This has been revised as a 1-star. So 4-star become 1-star. So same energy losses are being checked over here. So the rating is being revised by the Bureau of Energy Efficiency as the efficiency of the appliances going up. So new technologies are there, and efficiency is being revised day by day. When you are purchasing any electrical appliances which is star rated, you will have to see all these parameters. So in 2017, they have also added the capacity of the transformer up to 2,500. Earlier it was only 200 kVA rating. Now the rating has been increased up to 2,500 kVA transformer, above than the 11 kV class. So if we see the general ceiling fan, you can take the example of air delivery, where it has been mentioned that air delivery, base power consumption, 5-star power, energy saving, then cost saving. Then you calculate from air delivery 220 cubic meter per minute. Service value you can check according to the model. Then 3.2 power consumption is 69 watt if base case is there. In 5-star, the power consumption is 55 watt. So operation you are taking as 12 hours per day for 300 days. Then energy saving is 51 kilowatt hour per year. So you can calculate the cost as per the prevailing rate of the electricity, and calculate the energy saving from that. This is the journey from where it starts. Act enacted in 2001. Then first rating voluntary was started in 2006. Then 12 appliances were rated in 2007 to 2010. Then mandatory rating was given to 4 appliances: room AC, frost-free refrigerator, tube light, distribution transformer in 2010. Then it was increased 8 mandatory appliances in 2016. Then star labeling, now star labeling is there for, mandatory star labeling is there for 10 appliances. So this is how typical cycle for the each appliance is works. Then first selection of appliance, energy saving, then technical analysis, then technical committee approves, then implementation, then enforcement, then conversion, and then implementation and enforcement upgradation. So this is the system how the the B star labeling works. So first is voluntary stage, then transition phase, then mandatory phase. So this is the list of electrical appliances. There is 26 electrical appliances which has already been rated from 1 star to 5 star, and out of this, these are 10 which are mandatory, made mandatory. This is a frost-free refrigerator, then tube light, then room air conditioner, then direct refrigerator, then this one distribution transformer, color TV, then electrical geyser, then this one is room air conditioners, then room air conditioner, variable speed, then LED lamps. So these are 10, these 10 are mandatory, which in the market, there should not be non-star available. This is the facility given by the Bureau of Energy Efficiency, where you can check the labeling and compare that. This is the website, that is www.bestarlabel.com. You can log in it and you can get the all information regarding manufacturing, regarding BE, regarding laboratory. Every information is there. And you can also download the app, that is BE Star Label app is there. You can download on the mobile. Here you can search and compare your product by manufacturing, by energy efficiency. You can compare like as appliances detail over here. Then voluntary, you can compare with one manufacturer to second manufacturer. There is a lot of facility over there at the website is available. So you can search and compare the product. Any product you can search and compare it at the Bureau of Energy Efficiency website. So I would like to show you a small video on the star rating. You can see this.
India, one of the world's fastest growing economies. With the demand for appliances that make people's lives comfortable is increasing in step with the growth of the Indian economy. With the rising demand, the Indian market is flush with choices of consumers. With dozens of brands and dozens of choices.
We need to buy a new fridge.
I can't deal with this heat. I need a new AC.
I want a big TV.
I want to use appliances which will not only bring down my electricity bills, but also be good for the environment.
I need something which is efficient and something which is effective. Something which doesn't make my electricity bills touch the sky.
The features that I'm looking for are that it should have a good picture quality. It should consume less energy.
Buying an appliance is about more than just the initial cost to purchase. Appliances also cost money to run. High levels of energy consumption also contribute to climate change by releasing more carbon dioxide into the environment. It was to tackle this specific issue that the Government of India passed an Energy Conservation Act in 2001, leading to the establishment of Bureau of Energy Efficiency to work towards conservation and efficient energy use. One of the key thrust areas of the Act is the Standards and Labeling Program, which was launched to promote production of efficient appliances and equipment and to facilitate informed decision-making for consumers. The BE Standards and Labeling Program allows consumers and manufacturers and retailers to produce, sell and buy energy-efficient appliances. The star rating on a product affects the efficiency of the product. A 5-star appliance will be highly efficient. At the bottom of the label are the other important product specifications: brand, model, type, capacity, and efficiency. Each label has an energy efficiency parameter to define the star rating. Sunitha wants a brand new TV. Dhwani needs a new air conditioner this summer. And Sanjeev needs to replace his old fridge.
Inverter ACs which are coming with a star rating of 3-star and 5-star, which are almost 25 to 30% more energy saving products. If the AC is running for 8 hours and if it is going for a 6 month in a year, so if it is running for a 6 month, then you are recovering that cost altogether in a 1.5 year.
ये इन्वर्टर सीरीज भी है और 5-स्टार भी है, बिल्कुल इसमें सेविंग्स और ज़्यादा होंगी, बिल्कुल ज़्यादा होगा, उससे आप ज़्यादा सेविंग कर लोगे शायद.
Retailers can direct consumer decisions towards efficient appliances and can recommend the right products that will save energy and reduce costs.
We have launched a standards and labeling program, which is basically a star rating program. 21 products are already covered under this program, and 10 of these are mandatory labeling now. The last one was the LED bulbs, which have been brought in under this program. So these star labeling means the higher the star rating, the higher, less the energy usage. It saves a lot of energy, so it's a win-win situation for the consumer also.
The B Star Label app is a platform where the consumer can access all relevant information about different registered products. The mobile app provides real-time information. It also tells consumers how much money they can save if they buy a 5-star labeled appliance as opposed to an unlabeled one.
In future, Bureau also wants to add some more appliances like washing machine, microwave oven, so that the consumers will have a wider choice for their appliances.
There is a perception in the market that appliances with higher star ratings are more expensive. But in reality, the purchase price of an appliance is just one part of a long-term cost incurred, and the expense of running a less efficient appliance will lead to larger electricity bills over the years.
We have to be conscious ourselves. We have to go and switch off that one power point or charging point or whatever's on.
In the long run, in the beginning, you may have to shell out a little more.
Sure.
But in the long run, you save much more. So I look for the B label, especially the 5-star rating.
The stars, the better, always.
Simply leaving appliances on standby mode uses energy even if they are plugged in and not being used.
All switches must be turned off. You will be amazed by the amount you can save on your electricity bills by these simple measures.
Let's make it as a movement to buy products which are star rated and are energy efficient and save energy.
I also appeal all the retailers and dealers to convince their consumers to select for higher efficient appliances whenever they are going for a new appliance, so that they can save the energy for themselves as well as the country.
We are consumers and we are obviously part of it, and we should be doing our own bit.
Energy saved by me can be consumed by others.
I also want to ensure a better, cleaner, healthier environment for my children.
Here's what you can do to make a difference. Completely turn off all appliances when not in use. Buy only star-labeled appliances. Invest in a higher star-labeled appliance to save money in the long run. For more details, please refer to BEE's website, bstarlabel.com.
I trust the B label.
I trust the B label.
I trust the B label. I trust the B label.
So this is the small video. You have seen that how the star labeling works. So use B star label appliances, save energy, save environment, and save earth. So thank you very much for giving me a time for speaking on the energy electrical appliances. Thank you very much.
Thank you so much, sir. I hope my voice is audible.
Yeah.
Yeah, thank you so much, sir. So, the star labeling is necessary, as Sir talked in his presentation. We should all be buying star labeled appliances to save much on energy and on bills. Whenever we go buy any electronic home appliance, be it TV or refrigerator, we all know star labeled and 5 rated is highly recommended and highly energy efficient. More stars, more the saving. Sir has educated us on all the star rating of the appliances such as TV, refrigerator, ACs, tube lights, etc. He also taught us how to read and decipher the rating. It was really helpful, sir. We all should be really wise while buying these appliances. Thank you so much, sir. That was a really good video too. Now, next presentation is by engineer Shiv Batra, and he will enlighten us on lighting. Shiv K.R. Batra is electrical engineer and had worked in electrical and HVAC field for approximately 18 years, currently working with IBM India Private Limited as data center solution architect and innovative HVAC solution provider. Sir started his journey in power quality and worked around 9 years with Neptune India Private Limited as All India Technical Head at Developed Market in Middle East for power quality. He is LEED AP Griha Elevator and Trainer, IGBC AP and ECBC Master Trainer from BEE, CDCP, CDCS, GEM, AP, and member of ISHRI, Standard Development Organization Core Committee. He's conducted more than 80 seminars on energy efficiency in India, 165 ECBC workshops, and 41 energy simulation training programs on HAP. So we have a presentation by engineer Shiv Batra. Over to you, sir.
Thank you very much, Ramnik, for the introduction. I know few of the words might not be more advanced to the audience, like CD, CP, and CDCS.
Yes, I hope you can actually, enlighten them on the words. Thank you so much, sir.
Yeah, these are the certifications for the data center professional specialization. So, which is normally done by TIA, which is a global organization which conduct the training programs on the data centers. So now coming back to my presentation on lighting, I will just share my screen to everyone. Just 1 second. Yeah, I'm sure it must be visible too.
Kindly share your screen. Yes, sir, it is visible. Yes, sir. Okay. Kindly start. Yes, sir.
Yeah. So I know my time is 20 minutes, so I will try to finish up my presentation within the time limit. Good afternoon, everyone. As Hamnika already mentioned about my intro, so I will not get into the details of it. So let's straightforward go to the training program on the lightning component. So no doubt, lightning is one of the major energy consumer in the building, right? And it accounts for 15 to overall total consumption, and it comes to commercial building, it again goes to 20, 24, 40%. That's hold true when we are not using LED lights. Frankly speaking, if we are using LED lights, this percentage can straightforward be reduced down to something like 30% only. So for a household, you can consider something like 5 to 7%, and when it comes to commercial building, now this number would have been not more than 7 to 8%. But even then, that's a very important number, because I will not consider light as now a major energy consumer, but light as a component which can increase the productivity of my occupants, right? We have so-called neglected this part, right? But there are studies which are available which talked about that whenever you have a scarcity of light on your floor, right, it actually, the productivity of the people is reduced. And you can experience this, that whenever you have a low light, you will find that your own children is not comfortable in studying on the tables, and they move themselves from after just 10-15 minutes or 20 minutes. So psychologically as well as the mental level, light is a very important component. You look at the hospitals, you never find there is a scarcity of, or there is a dim light in the hospital. They'll put sufficient light so that the patient feel enlightened and they feel healthier. Now there are different technologies which has happened in last 20 years, and one of the biggest is no doubt evolution of LED lights. So when we talk about light, so we always talk about in watts. And I still remember the days when we were in schools, we go to buy a night bulb and we say we want a 0-watt bulb. Actually, there is nothing called 0 watt. It has to be, it will be some wattage. So Normally at that time it was 5, now it is 1, but there is a wattage. But the more important thing is how much lumen, that energy you are bringing out from the lamp. So normally you will find out a CFL lamp which is consuming something like 18 watt gives some 900 lumen output. So you will always find a light source wherever light bulb or any lamp that you purchase, they always write lumen per watt, which is called luminous efficiency, but we never read on it. If you buy a product from 4 different brands, right, starting from Philips to Wipro to Cisco or to any other brand, right, you will find out even for the same amount of watt, you will find different amount of lumens per watt, right? So example, a 10 watt bulb from Philips, Wipro, Cisco, Crompton or any other brand, the lumens per watt would be different by might be 1 or 2 lumen per watt differentiation. So we should be knowing that we should always buy a lamp with the higher luminous efficiency so that you get maximum output in terms of the light in respect to the energy it incorporates. So there are lights, there are TLD, there are T5 lights, and the more you use T5 lights, that give you better light with respect to the lower energy consumption. Now we talked about light, but what is the light that we need on our table? So that is something we never talked about, frankly speaking. We know lux level, we have heard this lux a lot, but frankly speaking, not with respect to the amount of light. We always remember somebody saying lux, we always remember those glamorous advertisement which comes on the news channels or on our TV channels. But lux is that what is the amount of light that we have in our desk, that's a lux level. So National Building Code has specified the lux level that should be there on your table. So now the question comes, how to measure it, right? So we will get the numbers from the National NBC 2016, which is available now. And but how to check it up? Do you need to call a auditor or some professional to check it up? I would say the answer is no. You have your iPhones, you have your Android phone, you can download the app. Your phone itself works as a lux meter, so you can check how much lux is there. And if you have a low lux, definitely there is a time that you have to switch on more light or relocate yourself near to the light so that you get the maximum light over there. Now the question comes, how to calculate for a room? So there's a mechanical, there's a arithmetical or a simple calculative formula which you can use to identify how much light you need, or you can do the reverse also. Let's say you want 300 lux, then you can do a reverse calculation. How much light bulb should be there in the room so that you get 300 lux. So either way you can do. If you're designing it, then you know the output. I need 300 lux. You know the area. Then you can calculate this much lumen output should come from the light source, right? And if you are going to an existing building, you can see how many lamps are there without even using the app or using the phone. You can see, okay, this is the total light installed in respect to the luminous, and then you can divide it by the area, multiplying by the utilization factor and maintenance factor. You can come to a very close number to the what should be the expected lux would be there in the room. So there is a calculation method. So one of the basic calculation, we did it for one room, that is this one, where we have 20 meter by 10 meter room, and we put number of lights, and these lights could be different in combination. So I will simply jump out to the this calculation which we work out for that room, which talked about 5 different options, right, that you can install in your room, and then you can compare it up with respect to the which is costing me more on a day one and which is giving me a better results in the long term, and more important is which is giving me uniform and a good light. So we have to see all these criteria. So if I start from sodium low pressure lamps, right, the 90 watt lamp, we will have to put only 6 lamps. It is consuming 540 watts. Luminous is okay. Lumen per square meter, I'm getting near about 300 watt per square meter. I will get 2, but it is uneven because my all corners mainly will be having a high intensity. Now, if I come down to option number 2, 3, 4, and 5, then I can see the option number 2, the normal lamps which we used to do earlier, was consuming more power. So power per square meter is more, right? So typically lamp is good, low, right? But uniformity is good. We get 32 lamps in a one room of 20 meter into 10 meter. Now, if you go to option number 4 or 5, which is your fluorescent T5 lamps or CFLs, right? So you get more number of lamps, 27 to 31. So uniformity is there in the complete room. And if I look at the watt per square meter is also low. Then you can, basis this, you can compare it up, you can calculate the annual bill, and you can come see yourself that the option number 2, if you use the incandescent lamps, which we used to do earlier, it takes 2 lakh rupees an annual energy bill for that room itself, considering 5500 operation and 6 rupees per square unit. Now, if I opt for the option number 5, my energy bill will be something like 42,000 or 31,000. So it had drastically come down by 75% basically, or more than that. So if you ask me, nowadays with the help of LEDs, we can really optimize that overall energy consumption of my building. Now, there are innovative technologies which can be used to improve the space, color of the room surface. Now, this is recall me up why whenever we go to an ancient or the old places, we always find white is considered to be the perfect one because it reflects more. So ultimately you require low energy and you get a better lux level inside the room. If your rooms are dark in color, it will reflect less and you will always feel low lux level in the room. So you will not prefer it for the studying, and that is the reason you will look at the school, look at the universities, look at the libraries, look at the hospitals, even the hotels. You will always find a more of a white color tone rather than any dark color tone for the light on the walls, right? So optimize light quality, reduce glare, right? And proper illumination ratio. They should not be some area you hang a more light, some area you have a low light. That should not be there. Mix of direct and indirect source. So direct source we know, indirect source we know that let's say we are bringing the natural light inside the building. While doing so, we should be very sure that wherever we are getting a natural light, we should have an option of switching off the artificial light in that area. It should not be that, okay, in the daytime, I had to sit near to the lamps or near to the window only because there I'm getting natural light. Other places I don't have light. So everybody move towards the window because when light comes in through windows, right? So it again brings a lot of heat. So if you look at the HVAC section, that is very important, which we called as a hotspot near the windows. So that is because you are bringing light as well as heat. So while selecting the glass, you have to make sure that it only brings light, not the heat. The color temperature, which we talked about rendering, that it should be supplementing your work and your activity rather than anything else. So consider light quantity. So separate task and ambient lighting. So if you are having a big hall and you have one table, then it's preferred to have study table with lamp rather than switching on all the lamps, right? So there are other things which you can integrate in your design is U-shaped, step back, skylighting, tinted, reflecting, all these things with the help of your architect friends or architects on board, you can actually integrate your light with the daylight combination. Now coming to the compliance part for the buildings. So the compliance part is very simple. You have to follow mandatory, whatever is mentioned in the ECBC, and there's a prescriptive method. So which says that, okay, whatever is written, you simply follow it and you will get the compliance. In case you are not in a position to follow prescriptive, then you can go for a whole building performance method, which will be taken up by a specialized energy consultant who will do it for your complete building. When it comes to overview part, so I can say mandatory have only two things, which is lightning control. So it's all saying that if you have a a good amount of anything, right, unless and until you control it, you cannot save it. So if you have even a money in your bank account, still you control it, you go regularly check, right, you make sure that it is not being wasted up. So that is nothing similar to that is a controls part. So in lightning, control is for interior and exterior light. So it should not happen that you have only one switch and you switch on and switch off all the lights together. There should be some mechanism, some logic behind when to on and when to switch it off. Then exit signboards. So this is 5 watt per signage, which is very much within the permissible available equipment available in the industry. When it comes to prescriptive requirement, you have to limit your electricity wattage used for the light. So what does that mean is, for example, you are putting X amount of light to get that lux level which is required as per the National Building Code and as per our requirement. but doing so, you should not consume more amount of wattages. So they have given the method as well as how to calculate and get it in so that you meet the requirement part. So when it comes to mandatory requirement, automatic lighting control should be there for 90% of the lighting area, right? Space control, if your area is more, then they're specified for this much area, you have to put one control, then you have to have a second control. Now, this control could be manual also, or it could be automatic also. It all depends upon how you want to do it. Daylight control, and that is also important. There should be a control, because sometimes it happens that you had a clear glass. Particular hours, 1 or 2 hours in a day, you get a huge amount of sunlight coming up from that window. Definitely you cannot sit there. So you can't change your location. So what will happen? You will put a permanent curtain, or you will make a curtain arrangement. So you have to make sure there should be some mechanism for controlling. Exterior lighting control for all exterior application, photosynthesis or astronomical time should be there. That okay, every morning, let's say at 7 o'clock in the summer, it should be switch off. That would not be right, because we get sun something like 5:30. So when summer comes up, the light should be switched off at 5:30. But when winter comes up, this could be switched on till 7. Similarly, in the evening, in winter, the sun sets at something like 5:30 or quarter to 6. But when it comes to summer, it is well shining till 7:30. So you have to make those adjustments according to the climatic condition, according to the where you are putting in. School, business areas, more than specific area, you have to put the exterior lighting control system. So these things are mandatory, right? You can't have any bypass for these things. You have to do these things, right? When it comes to prescriptive, which is nothing but what should be followed, which is good for you, right? So in our lifestyle also, it is good to wake up early, right? Take your morning walk, come back, bath, then take a shower, then breakfast. This is good activity. These are prescriptive things in our lifestyle, right? If we will follow these things, right? Let's say there is a lunch break at 1:30. Now looking at our current scenarios, under so much pressure that we people are working in, particularly in private sector. Now it's the same thing is happening even in a government department. We started skipping our lunches, right? Sometimes we are taking lunch at 4 o'clock. Then definitely we cannot have dinner at something like 8. So what is happening? We are not following the prescriptive or what have been decided or been guided by our gurus and our family members, that you should have this much interval for the lunch break and for the next food. So what is happening? We are not following the prescriptive approach. And what happens when we don't follow? Slowly we get into a trouble and we end up in going to visit a doctor. So similarly, if you will not follow the prescriptive things in your process of building the building, then you have to go for a whole building. Else, if you follow simple prescriptive methodology and apply them, right? So ECBC does not limit you to innovate, right? It only says you should consume less so that it saves energy. So while they have given the numbers, it gives a freedom also to architect, to consultant, to innovate. For example, in light, let's move to the next one. I will explain it to you. For example, these are the different lights. So there is no limitation. Definitely they should not be. For example, the second picture that is there for the dentist. If I go to a dentist and there is a low light, it may happen that he has to do a root canal and he has done something else. Similarly, for a photo shot, right? We went there for a photo shot for a bright and it becomes dull. So for these applications, there is no limit as such by the ECBC. It has to be as per the application requirement. Now, if you come down, there are the two methods which I mentioned about it, is called building area method, which talks about particular building type and how much light you are using, how you use it, which light you use it, which fixture you use it, and how you integrate with the daylight. No, nothing is there from the Bureau of Energy Efficiency in the ECBC. They only said, this is my office building and this is my area. Simply multiply by the amount of light that you're using. That's perfectly. If it is low, that's get compliant. So total watt of energy or the light fixture installed divided by the area, you give number. If this number is lower than this, you get the compliance, right? But that does not mean that you put less number of lights. For example, I need 10 lights in one particular room, but my number is going up. So one way is I can simply switch off or remove the lights. But the moment I do this, I will be reducing the lux level. So lux level has to be as per the National Building Code 2016. And then you should innovate or use new technology lights so that it consume less power and still deliver 300 watts, what the requirement for an office building. If you get better, if your target for super ECBC, definitely the light fixtures or the light has to be of a lower intensity. So the power should be 5 watt per square meter. Similarly, for the different applications, hospital as a complete building, shopping mall as a complete building, parking passage as a complete building. But imagine in an office building or in a hospital, I have OT only. Now, wherever we have OT, right? So the light intensity will be more. And if it is more, my power consumption will be more. So now you are getting into a space. So there is another method which is called space function method. So in a healthcare, you have emergency where you can use 22 watts per square meter, treatment 13, nurse station 9.5, storage 5.5. If you have a large storage in a healthcare, definitely your total power consumption will be low. But if you have a more operation theater and emergency area, then you cannot comply with the overall building area method. You have to go to the space function method. Then on the entrance part, right? So on the entrance, right, there will be with canopy, without canopy. They have specified this much should be the lux level as per the National Building Code, and you have to select the light as per which gives you the number compliance, which is 10 watt per square meter, 90 watt per square meter, 60 watt per linear. So this you have to follow, right? In case you are not able to design or able to achieve those lux level, and to achieve those lux level, you have to put more light. That means now you are not following no more any prescriptive numbers. Then what is an option? The option is you go for a whole building, right? For example, there is a challenge in metros, particularly Delhi, Bombay, Calcutta, that they cannot go for a morning walk. Frankly speaking, this is the scenario which I'm telling for my own, because my office and my house distance is around 32 kilometers, but it takes more than 2 hours. So if I have to hit my office at 9, I have to leave at 7. Definitely, then the backward works, and we ended up saying that, okay, I can't go for a morning walk. So I'm skipping the prescriptive approach. Then I go for a evening walk. So what happening? This thing will be taken up by the whole building simulation approach professional, which will tell you that if you're not complying on this, you can do something else. And so that my body or my building overall energy level is being maintained. Now, while doing so, we bring the documentation part into it, because sometimes it happens that we really do a very, very good work, right? But we don't have the documentation. For example, today we have a Taj Mahal with us, right? But if you ask me, is there any architectural drawings available? I don't know, but I feel there might not be, right? In terms of the amount of ventilation, how it has been created, the amount of light it has been created, how they have identified the location of their windows so that the moonlight come inside. Marvelous work done, right? It is not only about the Taj Mahal, it's all over places, all over old structures, but we don't have those studies with us. So similarly for our buildings also. So ECBC says that whenever you are doing a building design part, document it. And they have given the very good format to us that, well, let's say you are using daylight, make a tick. How you are doing it, make a tick. If you are putting a light in this, let's say room, what is the lux level? There is a calculation. There's a calculation, what is the energy used per square meter. So you just go on filling these things and it get documented, which will help you tomorrow when you go for the retrofit or enhance your performance of the building. So with this documentation part, which is the most important, the ECBC says that for every section, not only for light, for HVAC, for envelope, as well as for the power, you have to document all those things. I still believe, let's say 10 years back when we were doing a project, I found out that was the best building. But now if I look at, I say, oh, I made mistakes, but I don't have now documentation of those buildings. If it would have been there, I would have easily where I have made the mistakes and how we can improvise. So while this is a good opportunity that we have, we should document whatever we are doing, whatever working we are doing at one place, so that retrofit tomorrow is easier for us. Right. So with this, my presentations comes to an end, and I'm open for any questions related to lighting section. I would be happy to answer it.
I think there are no questions from audience side. Thank you so much, sir. Lighting plays a major role in our everyday life. And of course, natural light helps a lot in saving on bills and energy. And we all should make a habit of using the same. So, talk of Engineer Batra is very enlightening, as we all know that street lights, building lights, and lamp use considerable amount of energy. And with new technology and inventions, we have been seeing new products in the market every day, like LED lights, as Sir mentioned. Instead of conventional bulbs, saves more on energy, and by doing so, we are doing our bit on saving energy and saving the Mother Earth. Some thumb rules to actually calculate expected lux in a room which was very helpful. LED definitely helps down to bring the bill, so we also should be going for energy efficient lighting and lamps, which Sir wonderfully explained. So thank you so much, sir. Thank you so much for your part. And moving towards the next part of today's seminar, I request architect Pritpal Singh Ahluwalia from Creative Architects Patiala to give presentation on energy efficient building materials. Architect Pritpal Singh Ahluwalia is a fellow member of the Indian Institute of Architects and Institution of Valuers, accredited professional and member of Indian Green Building Council. He remained chairman of Indian Institute of Architects Patiala Subcenter, advisor to District Infrastructure Committee of Patiala. He served Chandigarh, Punjab chapter of IIA as joint honorary secretary. He delivered many presentations on various architecture and green building topics at various platforms where architects, engineers, and students were an audience. Over to you, sir.
Thank you, Ramnik.
Thank you so much, sir. Yes,
I think I am audible.
Yes, sir. Yes, you are audible,
yes,
sir.
Thank you. Thank you.
Yes, sir. You can
First
continue
of
with the
all, I would
presentation,
like
sir.
to congratulate Mr. Surinder Baga and the PEDA team for such a full event, in which even I have to wait for a 15 minutes, rather have to request somebody to exit to enter in this meeting because the house was totally full even after the relay on the YouTube of this event is there. So congrats to all the team members, those who had created this platform and celebrating the Energy Efficiency Week. And on the other side, if I see those who had spoken before me, they had given a very good presentations, Balkar Singh ji, sir, on the lighting and everything. So if we see about the consumption in the buildings, in the HVAC will take the maximum. Miscellaneous equipment consume the 16% of the energy, and rather fans may say somewhere it's the 5%. The heat gain percentage from the various building component is like glazing, walls. If we say the glazing will take the main, that is 55% heat gain, and 12% is from the roof. Then comes the walls and some internal equipment. The energy efficient materials, for the energy efficient materials, I think envelope plays a lead role in that. For the efficient building envelope, we need to study and very critically design the walls, roofs, roof skylights, and the glazing. Now, before going on it, before shortlisting the energy efficient building material, we must understand the building physics. Need is to understand the building physics. अगर हमें एक बार ये समझ आ जाएगा कि what are the parameters that we need to study from the materials, I think the most of the suppliers they give all the values in the their catalogs, and rather that are printed on the boxes also. So heat transfer is by the mean of, I am getting a bit fast because we are running behind the time. The total envelope of the heat transfer is by the way of the conduction, convection, and the radiation. So if we see this diagram, the conduction is in the handle, in which the molecules do not move, but like in a water, the molecules move and the heat is transferred. And for the radiation, that it need not to have any particular material. So convection, the transfer of the heat through the air circulation in a building. If you see the convection, the transfer of the heat is through the circulation of the air, and the conduction, the transfer of a heat through the two parts cause the temperature difference when there is a temperature difference. And in radiation, the process of heat is emitting as the particles or the waves. The sun radiates the heat to the walls and the roofs. The heat conducts through the roofs and again it radiates inside to the ceilings, and the walls and the ceilings conduct the heat through the material and radiate through the building. So to make, as we had already seen, that main part of the energy consumed is in the HVAC to make the ourselves more comfortable. So for making, if in case at the source, the difference between the means energy conservation and is that कि हमारा सोर्स पर ही हम डिजाइन कुछ ऐसा कर लें बिल्डिंग मटेरियल्स को कि हमें रिक्वायरमेंट ही कम से कम पड़े HVAC की, फैंस की, एंड द पर्सन हु आर ऑक्युपाइंग द बिल्डिंग शुड फील अ वेरी कंफर्टेबल. सो वी before finalizing any material, we need to study the properties of the material and the mode by which the heat is transferred. So the properties, if we study for the properties, the mode of the heat is, that is conduction. Conduction affects the thermal properties of materials, and the effectiveness is by the insulation. So in ECBC also, the main role is U factor and the R value, that is for the roofs and the walls. Then comes the convection. Convection is by the air movement. And what the ECBC says, that is the ceiling. Building envelope ceiling requirement is given in the ECBC. If we talk about the radiations, the indirect and the direct solar radiations affect the R value of the roof and the walls and the cool roofs. These are the various properties we need to study. If we go for the conductivity, that is watt per meter Kelvin is the unit. Conductivity means कि heat कितनी inside जा रही है, उसका एक unit है. Resistivity means जो आपका product material है, how much it resists the heat from the outside to get inside. So this is the main, rather to pass the heat from the material. And for the R value, if there is a particular thickness is there, then D upon K will give you the total R value. So conduction is 1 upon the R value, that is inverse of the resistivity. For taking the total conduction of the multiple layers, we need to have the total U factor. That the total U factor is equal to 1 upon R value of the total. So we need to study if in case we are putting the 3-4 materials. For example, at the roof, if I am putting some insulation material and then there is a RCC wall, or we are putting a mud and a tiles over it, then the total U value is to be calculated by a particular formula. For that formula that I am referring to this is that the R is equal to the thickness of a material divided by the thermal conductivity of a material. Generally, in case you are taking some materials, the R value and U value are printed on the catalogs, or we can inquire from the vendors also. For example, there are different 2-3 examples I had given in this slide. The total thermal resistivity for the multiple layers, we need to calculate the RT first with the thickness divided by the resistivity, and also in that indoor and outdoor surface temperature coefficients are to be added, and after that we will get the total R. And for the after getting the total R, we can 1 upon total R will become the U value. Now there is a vast difference between the various materials we use. That for example, the RCC wall, the U value is 1.95. In the thermal value material, if you see and the bottom there, I have given one various differences between the U value. Like concrete have the 1.6, brick has 1.45, and the fly ash is 1.2, and using AAC block is 0.8. See that is quite differences. How much conduction is there? In case you are putting a RCC wall, it is having a higher value, that is 1.6. In case you are putting the AAC block bricks, then it will give only the 0.8. So there is a vast difference of say 50% is there. So before deciding any type of materials, we should, especially in the building envelope and the outer wall, I personally, when we are doing the this ECBC analysis and ECBC reports, we generally recommend for the AAC blocks only due to these or values. So because AAC is very good for which avoid the transfer of heat from the outside to the inside. Yes, XLP its line is for this can be used for the underdeck or the overdeck also. Even underdeck roofing, it is very good. So if we compare the overdeck with the underdeck, see, always I personally believe that overdeck insulation is far better than going for the underdeck insulation, because you are breaking the heat at the very first instance only. In case the roof insulation can be insulated either by the overdeck or a underdeck, the overdeck insulation is always preferred so as to avoid the absorption and the retention of a heat in the concrete or a outermost surface. The underdeck insulation can also be considered, but the thickness of the insulation should be higher, because that and the typical insulation roof over the deck is low. But in case we are doing the underdeck insulation, we need to seal it in a very proper way. The benefit of the deck insulation is it protects the heat from entering inside the house. It increases the cooling efficiency of the house or a building, whatever, that decrease the cooling time also, and the decrease in the energy consumption in the cooling moistures. Now, again, the heat resistant service tiles, if we are putting it at the top, these are the very efficient designing. In case if you are designing the rooftops, instead of using the clay bricks or some other materials, we should use the heat resistant surface tiles, which reduce the energy cost, improve the indoor air quality, prolong the building life also, and the exceptional durability, enhance the aesthetic appeals if we see from the outer side. Generally, white light, Surinder Baga sir ne bhi, he had also shown in his building and presentation, they are putting the white light so that the maximum light should be reflective. वहां से reflect हो जाएगी तो solar radiation जो है उसका effect comparatively जो है कम होगा. तो you see the SRI given in the diagram. So building envelope, there are the various walls need to be insulated, fly ash bricks or AAC blocks. Even you can create a cavity wall or the hollow blocks. And for the roof insulations and the clay tiles or the other tiles which are preferred to be used. And then comes the extensive glazings. Glazings we are using lot in these days, but tremendous daylight is required inside, but heat ingress also. We need to balance both these things so that ये ना हो कि बहुत ज़्यादा हम glass use करने के बाद इतना ज़्यादा एक once I moved to my friend's office in which they were using the lights in a daytime also. मैंने पूछा भाई इतना शीशा है आपके पास, why you are using the daylight? Because that glass was creating a glare inside and they were using the means अंदर सब पर्दा वगैरह लगा के उन्होंने बंद किया हुआ था. So interesting part is क्या है कि उससे again अंदर light कम होगी and they are using the light. So in that case, even that after using the lot of glazings, daylight was not inside. So we need to have the balance of both things. High performance glass and glazings can be used. If we talk about the fenestration, then heat transfer in the from the glasses or from the fenestration in the two way, that is solar heat gain coefficient SHGC and the shading coefficient SC. Visual light transmittance VLT also plays a lead role before deciding the glass. Solar heat gain coefficient is the ratio of a solar heat gain that passes through the fenestration to the total incident solar radiation that falls on a fenestration. जितनी की सारी light जो radiations पड़ रही है उसमें से कितनी light को वो कितनी solar heat को जो है inside जाने देता है, solar radiations को जाने देता है. So that plays a lead role while you are deciding your fenestration. So indicates how the well fenestration insulate heat caused by the direct solar rays. The lower SHGC means the lesser heat transfer into the buildings through the windows, depend upon the properties of the glazing. Materials and the windows are either operable or they are the fixed materials. In the hot climates, especially where we are there, hot climates, or even in the composite climates, the SHGC is the more significant than the U factor for a glazing. The solar coefficient SC, the solar heat gain coefficient has replaced to the shading coefficient as the standard indicator in the window shading ability. The relationship between the SC and the SHGC is SHGC is expressed in a number from 0 to 0.87 and SC is a number between 0 to 1. SHGC, to calculate the SHGC, that is SHGC is equal to SC divided by 0.87. SHGC may be expressed in the terms of a glass only and may also refer to the entire window assembly, but the SC is typically indicated to the glass alone and does not take the consideration of the effect of the frames. Now, if we come to the VLT, these all we need to understand the terms basically, because as for outer opaque materials, we need to have the understanding of the U value and the R values. And then if we are deciding the glass, then we need to understand the visual light transmission and the SHGC factor. So the fraction of VLT through the glazing affect to the daylight and the visibility. कि कितनी विजुअल लाइट जो डे लाइट अंदर आ रही है, अंदर से बाहर बंदा कितना देख सकता है, बाहर से अंदर कैसे है. VLT is concerned with the visible portion of the solar spectrum and opposed with the SHGC. Typically lower the SHGC, lower the VLT. Higher insulation properties glass will reduce the daylight. But there are different other using double glaze and all, we can manage both the things, VLT and SHGC. Higher the VLT, more the light, and you Yeah, I am audible now?
Yes, sir.
Hello?
Yes, sir, you are audible, sir. Please continue, sir.
Okay, okay. I think there was some problem here, no? There's due to some, yeah. So screen is visible, no?
Yes, sir.
If I see
yes, sir, please continue.
to this, let's see to this. Okay. Let's see to this slide. In this, this is, I think there is some internet connection problem. I apologize for that. If we go for the Antillo single glazing, that's LT is 67%. Shading coefficient is 0.8. Rather, if we go for the double Antillo glazing, then it is solar factor is 0.63, hardly matters, and the U value is for putting an air inside, it becomes from 5.7 to the 2.8. So various U values, like having even a 5.2, these are the various examples. We can have the SHGC of the various other things. Again, then another part comes in the materials is, that is the outer frames. Outer frames, if we are using the traditionally like the woods and even the standard aluminiums, which we are using, it has a lot of effects onto the air conditioning and also to the energy efficient part of the building. So heat transfer rate is good in case you are using the UPVC or the noise reduction, fire, no doubt these all are the benefits. But if we are using the DGU with the UPVC, that is the perfect combination. Using, for example, in the buildings nowadays, we are trying is used to use the AAC blocks and using DGUs along with the UPVC windows. Rather, this in case we are using the aluminium, we should use some thermal insulation or a thermal break in the this is a coupling aluminium section which shows there is a thermal insulation. So this type of thermal break sliding windows example is also there. So we can use, in case we are using the aluminium, then we must use some thermal break insulations in that case. This is very interesting material, which is nowadays we are using this in the various high performance required with the high heat of fusion, in which the melting and solidifying at a certain temperature, it has the capability of storing and releasing the large amount of energy. Heat is absorbed or released when the material change from the solid to the liquid and vice versa. Thus, the PCM is classified as latent heat storage LHS units. ये इतनी इंटरेस्टिंग चीज है, ये आज लाइक यूज इन द वेरियस स्ट्रक्चर्स. ये अगर हम चले जाएं तो इवन सियाचिन एंड वहां पर जो कुछ फौजियों के यूज होते हैं कैंप्स, वहां पर पीसीएम यूज हो रहा है आजकल. ये बिल्डिंग मटेरियल्स में यूज हो रहा है. एंड दिस इवन वी हैव यूज्ड दिस इनटू द अगर आपने जो ये मोबाइल के टावर्स लगते हैं, टावर्स के साथ एक छोटा यूनिट लगता है, ये जनरली यूज पीसीएम इन दिस आल्सो. तो उसमें क्या होता है कि जब उसको चाहिए होती है, जब दिन में बहुत ज्यादा गर्मी होती है तो वो हीट को अब्सॉर्ब कर लेता है और अंदर टेम्परेचर ठीक करता है. और जब शाम को इनके बहुत ज्यादा ठंड हो जाती है, थोड़ी जाती है, तो वो हीट को रिलीज करना शुरू कर देता है. दिस इज इसमें थिकनेस बहुत कम के अंदर वी कैन यूज द कंस्ट्रक्शन लाइक इन केस वी आर यूजिंग 28 centimeter of plywood or the lightweight construction curves say something 2 to 6, then that all is equal to the 1 centimeter of a PCM. So the 7 metric ton of PCM incorporated in a building produce the same effect to the 2000 metric ton of a concrete or a similar building material. Hence this will also in the overall, if we say the इसमें हमारा ओवरऑल कॉस्ट ऑफ बिल्डिंग भी जो है वी कैन सेव इट वेरी इजीली. लोअर द थर्मल स्टोरेज ऑफ ए मास, सूनर इट विल गेट द ओवरहेड. सो दिस इज वन एग्जांपल इन व्हिच दैट टेम्परेचर मॉड्यूलेशन ऑफ द इनटेक ऑफ एयर इन a greenhouse using the PCM and a PCM panels and a retrofitting installed as a thermal energy storage in the greenhouses. During the daytime, PCM absorb the heat without allowing to the any increase in house, and the absorbed or stored heat is released at the cold ambient during the night. Are also one studies for there. So energy efficient lighting, I think I will not go much for it because sir has already explained a lot of these things. But yes, for the light controls area, we should provide the various light controls like day lighting, sensors for the exterior lighting controls, and even manual switches, lapse time switches, clock switches, energy management system controls, photo cell controls, occupancy centers, switch, everything, many things as sir had already explained to you. That dimming controls like the power reducer, step dimming controls, these are the various equipments by which you can have the energy efficiency. In which the switch off is need to be delete like in a day control or a exterior lighting control, automatic lighting control in which that includes the occupation sensor, then the meeting rooms, conference rooms, or a schedule based are already explained. So thank you very much. Time was very short, so we are not going very much into the details. I think Anuj sir is also waiting very eagerly for his time. We are we are running out of the time. Thank you very much. Over to you. Thank you.
Thank you so much, sir. That was a wonderful presentation on energy efficient building material. As we all know, energy efficient building materials have put a major impact on our construction business now. So using energy efficient material, of course, now again helps on reducing the construction cost and then operational cost. And then we all know in the succeeding years we all come to know कि हाँ energy अगर efficient materials हम use करते हैं, even if the cost is higher, तो उसका payback period में in the then successor years तो हमें पता चल जाता है हाँ we actually made a right choice. So thank you so much sir, आपकी presentation बहुत अच्छी है. Thank you so much sir. And now we have our next presentation by engineer Anuj Agarwal from Ambience Chandigarh on HVAC. Sir is a mechanical engineer with 30 years of experience. He is IGBC AP Greha trainer, member of Institute of Engineers. After completing around 17 years of work in corporate, he started his own MEP consultancy firm in Ambience, namely Ambience, in 2007. Successfully, he completed over 300 projects in 13 years, including IGBC gold-rated projects and Griha 4-star projects. Founding President of ISHRE Chandigarh Chapter, Founding Joint Secretary of FSII, Chandigarh Sub-Chapter, Member of BOG of ASHRE, Chandigarh Chapter, Member Governing Council of GEM. He's been a visiting faculty for services at Chandigarh Institute of Architecture, Chandigarh, and has delivered many lectures on sustainability, HVAC on different forums. Over to you, sir. Your presentation, please. Engineer Anuj Agarwal. I hope you are here, sir. And before starting this presentation, I would request everybody in the audience to please fill a feedback form, which is now in the chat box. Kindly click on the link. It is just 5 to 7 minutes feedback form. It has hardly 10 to 12 questions in a yes or no format. And I will really request the audience to fill the feedback form, as it is going to help our future webinars and will help us in a lot of ways. Thank you so much. Engineer Anuj Agarwal, are you ready?
Yeah, I'm ready. Thank you, Ramnik, and thank you, Mr. Ahluwalia, for giving a good presentation before me. I had been listening to the presentations by Mr. Baga and Mr. Balkar Singh, Mr. Batra, Mr. Ahluwalia. We had been covering a host of topics from architecture to lighting to star labeled, which is the BE requirements, and energy efficient building materials. So, and also understand that a lot of ECBC engineers and some government departments engineers are today attending this seminar. So in my presentation, which will be a quick 15-minute presentation, we will have an overview of air conditioning, which may be just a 5 minutes overview, because we need to brush up our things which we have studied 20-30 years back, and then we will go to certain aspects how we can make HVAC systems work better for us, particularly for the way the energy is becoming costlier and how to save the energy. Right. Thank you. Let's start. So when we talk about air conditioning, why air conditioning is required is because we feel too warm, or it is too cold, or too humid, or too stuffy. So we, in either of the conditions, we do not feel comfortable. So we say the building should be air conditioned. So what air conditioning should be doing is it controls temperature, humidity, air purity, and air motion. Now, the last three items, humidity, air purity, and air motion, are more important than the temperature. Although generally people put more weightage on the temperature, because other three aspects actually means the quality of air conditioning. Now, it is basically heat transfer from one place to another. So how do we feel air conditioning is basically, if there is an evaporation, we feel cooler. And if there is a condensation, we feel hotter. So that's how the air conditioning works. The heat which is transferred from one place to another is basically two types of heat. One is latent heat and another is the sensible heat. We are all aware of both of them. Latent heat is something which cannot be measured, and it is much more than the sensible heat for the building, which can be measured. So like I told, whenever there is an evaporation, we feel colder. And these are the basic four main components of an air conditioning system. The compressor is the heart, and it takes maximum energy. And in ECBC in 2005 and subsequently in 2017, we have specified the coefficient of performance of the machines, which are basically the amount of energy the compressor is going to use. And then you have condenser. Condensers can be both air cooled and water cooled, and this depends on the type of the systems chosen. And then expansion device, which is there inside, built into the system, and the evaporator coil, which is at the indoor unit, or the AHU, or whatever we call it. So this is the representation of the air conditioning system on a basically pressure enthalpy diagram. wherein we can see there is a cooling coil at the inside, and at lower temperature where the water is entering at 54 or 44 and going back at 54, and the heat is rejected at the cooling tower, which is working between 85 to 95 degree Fahrenheit. So this is a typical installation of a room AC, which is ubiquitous in all the old buildings, old offices. Most of the places you find this window AC, which is one of the most inefficient type of system, and it only controls the temperature. It does not do anything on the humidity or air purity, because there is hardly any filtration built into it, or air motion also. And but nowadays there is a because of the ECBC, still one of the cheapest way of doing air conditioning. They have specified certain COPs for this, and which has improved the energy efficiency, but then this is there. The second and the most commonly used system is a central plant system, be it a chiller based system or a VRV based system, wherein there is a remote indoor unit which can be installed in the schematic drawing which we have shown. The remote indoor unit is outside the room. It can be inside the room or outside the room, and there is a duct which is supplying the air into the room there, and there is a return air which is picked up through a duct ideally, or through the void between the false ceiling and the true roof. Now, in both the cases, what happens is the coil which is there in the AHU or the FCU or the other unit, where we can control not only the temperature, we can control the humidity, purity of air by putting more filters into the system, and obviously the air motion is controlled by the grills, because they are distributed along the entire surface of the area. So this is how a system is there with a fan coil unit, and this is where ideally a system should be there with a fan coil unit with a treated fresh air unit, which is treating the fresh air which is required for maintaining proper ventilation things. As per ASHRAE 62.1, there is a ventilation code which is there, which is revised every 10 years, and the present ASHRAE 62.1 specifies what are the ventilation standards. There are ventilation standards for each and every type of occupancy, from classroom to office buildings to auditoriums to canteens, workshops, in hospitals, OTs, everywhere. So if we go through that, we get different fresh air standards, right from 5 CFM per person. If we are talking generally, people are using what is the fresh air you have taken. So they will say either it's 1 air change or 5 CFM per person or 10 CFM per person, but that's not the right way of taking it. The ASHRAE code gives you which converts from 5.5 CFM per person to 18 or 20 CFM per person also, depending on the usage of the building. These are the climate zones for which we must have spoken earlier also, because the entire country is divided into 5 zones, which is composite, which is where we are lying, then hot and dry, basically Rajasthan and parts of Gujarat and other places. Moderate, which is in certain places like Bangalore and other. Humid is Calcutta or Bombay, and cold places like Srinagar, Shillong, Shimla and other places. So typical ambient ranges from summer temperature ranges from 15 degree in Srinagar to 50 degree in Nagpur. That's the type of the range which we find in India. So it's pretty diversified, and that's why we are using all type of air conditioning systems, and no single system can be said as the proper system for a particular type of building across the country. So now coming to the consumption, this is the sector-wise consumption. We see there's a lot of consumption in commercial, industrial, and residential. In fact, agriculture also, which is neglected, is using, but that is using in pumping motors and those things which are very inefficient, and a lot of work is being done in that area also, which is I'm not going to cover on that. But yes, we will be concentrating on commercial and industrial and residential, which consumes almost 65% of the total energy consumption. and out of which about 32 to 40% is used in HVAC, which is a pretty high percentage of energy which is being consumed in air conditioning. Now, as per Energy Conservation Act, actually we didn't have an energy conservation for a country like India, as diverse and as technically sound. We didn't have an Energy Conservation Act till 2001, when it was brought in and a Energy Efficiency Bureau was set in, and a clear mandate was there for the government that we should be saving energy. We should be trying to save the energy, because energy saved is energy produced. Because our energy consumption is among one of the most heavy in the world. I think we are still at number 4 or 5 in the world in terms of total energy consumption, and obviously the leader is USA. And this energy movement actually started, and it got impetus with the IGBC green building, the CII Godrej building, which came up in Hyderabad in the year 98. And after that, the people actually got aware of this energy conservation. So that's why this government of India had set up this Energy Conservation Act, which was there to reduce the energy conservation. And it was mandated that all the buildings which are having connected load of more than around 500 kilowatt has to have energy conservation energy audit, mandatory, because and use the products as per the act, which has now been reduced, I think, in Punjab to 100 kilowatt, and still the compliance level in India is not very good as what we want, but I'm sure this is catching up and things will improve in days to come. Coming to Energy Conservation Building Code 2017, which was the second edition. The first edition came in 2005. And in 2017, they had specified the minimum efficiencies of the chillers, which is the maximum power consuming equipment in the entire system. And if you see, this was specified considering the capacity of the chiller. So if the chiller is less than 75 TR capacity, the an ECBC compliant building should have a minimum efficiency of 4.7 COP. Whereas if the same building building has a bigger compressor, say a 400 ton compressor, the COP will increase to 5.8. Means there is an increase of 20%. So this is because of the technological limitations that we cannot produce a 5.8 COP chiller for 75 ton. It will be prohibitively costly. So that's why this graded system is available. Similarly, for this was for water cooled machines. Then you have energy efficiency requirements for air cooled machines, which is there. Generally, air cooled machines for larger capacities are not available because they are too bulky to install. So the air cooled machines are for the maximum of 300 tons are available in the market. And now the VRF. VRF is also there, and if you see, the VRF is used only for ECBC compliant buildings. There is no code for ECBC plus or super ECBC, although certain rating standards like IGBC or this GREHA, they specify certain COPs for getting points, and if you are having a more COP machine, then you get a better point. And since these standards in VRV are pretty low, because nowadays companies are coming with COPs of 4 and above, so I think they should be seriously reviewed and improved upon, because with this thing, many people are doing very inefficient systems, and that's how many companies are surviving. Now, coming to the comfort zone, we should ideally maintain the temperature of the air conditioning indoors between 68 to 78 degree Fahrenheit, which is 20 degree to 26 degree. And if I have to break it down further, in winters, you should have around 20 to 23 degrees centigrade inside the room. And in summers, you should have 24 to 26 degrees centigrade. Whereas generally people try to keep your AC at 22, which is wrong. It should never be at 22. It should be, in fact, considering all these things, Government of India has brought up ordinance also that the minimum temperature for all ACs to be set as 26 degrees centigrade, which is a good move, and I think it should be increased only. This is as per the studies done in America, and the comfort levels were seen with the metabolic studies or on the human beings were done at which their mind body is working best. These were the temperatures observed there. So now, how do we design an efficient HVAC system? An efficient HVAC system can be only designed with having the right temperature, not the cold temperature. High efficiency chillers or VRF, that is specified in the ECBC code. The air cooled or water cooled system, that obviously is designed by the type of area we are in, the type of resources you are having. Energy recovery ventilators to recover whatever energy we can recover from the exhaust from the building. Variable frequency drives to control the speed when your requirement is low. Proper sizing of AHUs and ducts, which is most important, because if you are not putting the right size of the equipment, you are not getting the right type of temperatures. And we should not go with the perception and marketing, because these things are most damaging. We generally have a perception that certain brand is better, but it may not be the best. And then we should also look at non-conventional methods like geothermal, air tunnels, earth air tunnels, and marine air conditioning, solar air conditioning. These concepts have been developed and are being used. And as of now, these are mostly an experimental stage and only for showcase the technology. But I'm sure as the things are moving, things will gravitate towards non-conventional methods. Now, these are some of the mandatory requirements as per ECBC for designing an efficient air conditioning system. The ventilation and this should be as per the standard SQC 2.1. Minimum equipment efficiencies, again ECBC has specified, which is again taken from ASHRAE handbooks. And the controls, proper controls should be there, and time clocks and other BMS systems should be there, so that the system closes once it is not required. It is not that the system keeps on working and we are wasting a lot of energy. And insulation is another area where they have put a lot of emphasis, because if you are not putting a proper type of insulation, you can lose up to 2 to 5% of your energy cost, which is huge. And they also require outside air economizers, which are basically treated fresh air units with energy recovery wheels or energy recovery ventilators. Variable speed drives on pumps and fans above a certain capacity, so that we can save on low speed when the pumping is not required to full capacity. We can, by adopting all these measures which have been listed in previous 2 slides, we can save up to 25 to 40% of energy which is being used in an air conditioning system. Typically, if I say when 1990, when we started our career, an air conditioning system used to consume almost 1.5 kilowatt per ton. Today, the benchmark has come to 1.1 kilowatt per ton, which is 0.4 kilowatt. Now, if you consider that we are selling almost like 6 million split ACs in this country every year, and central plant for worth almost like 20 lakh tons. So the amount of energy which is being consumed in air conditioning, which is phenomenal, and the savings can be extremely big for our country, which is a growing country. Now, these are the type of compressors, the scroll compressors. So how the scroll compressor works, the reciprocating, and the screw compressor. So this is all I have, and any questions from the group, if there are any, I'm ready to answer. Thank you.
Thank you so much, sir. We will have a question and answer session in a bit. So thank you so much, sir. That was a wonderful presentation. Sir's presentation has been very informative and very enlightening as ACs have become an important part of our lifestyle because of the harsh conditions in many zones of our country, as we learned in the first talk by Baga sir. It is learned that keeping the setting of temperature saves, if you actually keep it on energy saving mode, there are energy saving modes in AC. They actually, help us to save energy a lot. And also, we consumers should choose five-star ACs, five-star rated ACs, as even Balkar sir in his presentation told us to actually be very wise and then buy our appliances. They consume very less energy, and even if they are costly, the payback period is definitely seen in the following years, and we actually save on energy bills and we save energy. So 6 million ACs in a year. Wow, that is a huge number. That is actually a huge number. You know, this was the last talk of our presentation, and then we will be moving to our last part of the seminar. In all the presentations, we've encountered that energy efficiency is one of the most important part of our life, because renewable energies are in abundance, but non-renewable sources of energy, just like the fuels, the coal, we have seen an evolution of the we have seen sources of energy, the evolution in a lot of years. So energy efficiency is really important part of our life. So moving to the last part of today's seminar, I actually now request architect Dinesh Bhagat to deliver a vote of thanks and concluding remarks. I think we have architect Dinesh Bhagat with us.
Yes.
Architect
Am
Dinesh
I
Bhagat.
audible?
Yes sir, you are. Yes
Yes.
sir, you are. You're visible too. Yes sir.
Uh, Thank you, Ramnik.
Thank you.
Very good evening. It's my pleasure to propose a vote of thanks for contribution of each and everyone who has gone live onto the seminar and made it a memorable webinar. We would like to express deep gratitude to Punjab Energy Development Agency for giving the opportunity to meet and exchange such knowledge, such knowledge at such a short notice. We would like to convey thanks to, first of all, to architect Shruti Hemant Kapoor from City Institute of Architecture and Planning for her welcome note, and architect Shilpa Das for her introductory address. We are also thankful to expert speakers Bhaga sir, Balkar Singh sir, Shiv Kumar ji, Aluwalia Saab, and engineer Anuj Agarwal. Special thanks to all officials from PEDA for their valuable support into this very particular session. And even we are expecting more support in other forthcoming sessions. We are grateful to Department of Local Government and empaneled ECBC professionals for attending this program, and Sakar Foundation Chandigarh for conducting the program. We are grateful to office bearers of IIA Punjab and Chandigarh chapter for supporting this program. Our special thanks are for all of you for spending such a valuable time for our sake. Thank you very much. And indeed, it was very memorable. In the last, I would like to thank Ms. Ramneek for her wonderful comparing of this webinar, and our deep gratitude to media personalities and other wholehearted support for this program. Thank you very much. That's it.
Thank you so much, sir. I would like to also announce that feedback form will be sent to the audience who are present here today, and filling the form will, and those who are filling the form will be giving certificates. Thank you so much, Architect Dinesh Bhagat. That was quite a wonderful end to our webinar. So it is a simple fact that world's reserve of fossil fuels are running out, and depending on the rate of use, and therefore if the consumption of these forms of energy are reduced, the existing reserves will last longer. So the largest improvement in energy conservation in the next 2 decades are projected to take place in India, China, and the European Union. In India, implementation of more stringent policies like PET scheme, energy efficiency standards for vehicles are expected to make a substantial contribution. Energy efficiency offers benefits at different levels of economy. Yes, and people are actually becoming energy efficient, as we can see in the example shown by the eminent speakers in their PPTs. So that is clearly showing up. The amount of worldwide energy reserves and life is variable according to the source of information used. Thus, at some time in not too distant future, maybe less than 100 years, oil, gas, uranium will no longer be available. So we have to make our every effort to reduce the world's energy demand. The earth provides enough to satisfy every man's need, but not to every man's greed, said by Mahatma Gandhi. And there are some hard facts on why energy conservation is a must. Because most of the energy we use most of the non renewable energy, we cannot be reused and cannot be renewed. So we save a country a lot of money. We will save India a lot of money when we save energy. And an old saying describes it this way: the earth, the water, and air are not a gift to us from our parents, but a loan for our children. Hence, we need to make energy conservation a habit. And then again, I would like to congratulate PEDA and BEE. I would like to congratulate PEDA, BEE for letting us encounter this informative event on energy conservation. And I would like to again extend my thanks to all the officials, our audience who've participated in our webinar, the eminent speakers, our supporters for being here with us. So it is our bit and our effort that will help us save our environment. Lastly, I would like to also add that BEE also broadcasts radio programs like Bachat Ke Sitare, Dost Hamare on AIR Air FM Gold in 20 languages, which spread awareness about star labeled appliances in India. I hope you would tune into that channel. And there is also an app to check the performance of your star label bought appliances. You can surely get that app on the App Store. And now, before that, I would like to announce again that the feedback form will be sent to you in your email IDs, the registered email IDs. And I would really like the audience to fill that feedback form. It's going to take just 5 to 7 minutes and in just 10 to 12 questions in a yes or no format. And surely e-certificates will be given to all those people who are going to fill up the feedback form. So thank you very much for your kind attention, the audience, and I hope you have a remarkable evening ahead. Thank you. Thank you very much. Thank you, everyone.